Today we're going to use both substitution and elimination depending on the structure of the problem and kind of get an idea of when to use which one. Alright, so substitution is a technique we've been using on these, and I'm going to go ahead and use substitution on this one as well. You recall that if you have a system of equations, you have a linear equation with x and y in it, a second linear equation with x and y in it, creating two lines. These lines intersect in one point, possibly. Substitution is the technique we've learned so far. That's how I'm going to solve this. Now, one thing I've mentioned about substitution, that if you're going to use it, you need to get either x equals or y equals. It doesn't matter which one you choose to do. It doesn't matter which equation you choose to do it in. But in some cases, it's easier than others, and that's what I need you to recognize. What makes it easy, what makes it more challenging. So in this setup, solving this equation, top equation for y, involves just moving 3x to the other side, then it's done, right? So solving that for y is very simple to do. If I take the bottom equation and solve for x, I simply have to move y to the other side to get x equals. Very simple to do. If I want to take the bottom equation and solve for y, I just have to move the x to the other side, getting y equals. Very simple to do. All right, so all three of those would be simple. Any one of those three would be fine, and the amount of work and the difficulty level will be the same for all three of those choices. If I choose to take the top equation and solve for x, I have to move the y over first, and then I divide everything by 3. All of a sudden I get this unpleasant fraction. All right? And I want to avoid unpleasant fractions because although fractions aren't terribly difficult to do, they're not as easy as integers. So if we can avoid fractions, we have the option to avoid fractions. It's worth doing. So if this were me, getting the top equation solve for y, bottom equation solve for y, or bottom equation solve for x, one of those three choices would be the one I'd pick. Solving the top for x does not seem to be the best choice in this scenario. So I'll let Journey pick. Top for y, bottom for x, bottom for y. What do you want to do? Just pick one. They're all the same. Top for y, bottom for x or y. Top for y. Perfect. All right, so Journey wants to solve the top for y. So to make that happen, I'm going to take the 3x, which is here, and I'm going to move it to the other side. So the top equation transforms from what it is, 3x plus y equals 17, into positive y, which is what's still there, equals positive 17. Those two things stayed where they were. They stayed the same sign. And then 3x moves across, the equal sign becomes minus 3x. Okay. That's the requirement for substitution. An expression looking like that, one letter, either x or y, equals everything else. That came from the top equation, so now the substitution goes into the bottom equation. I take the y that's in the bottom equation, and I'm going to put this expression that equals y in place of that y. So the bottom equation, which currently says x plus y equals 7, becomes x plus parentheses 17 minus 3x equals 7. If you change one thing into more than one thing, always put parentheses right under substitution. It's just good policy. The usefulness of that step is I went from an equation with two variables, x and y, into an equation with only one variable type, x. So now this is solvable by normal means. Okay? Plus parentheses really doesn't do anything. So the parentheses, although I always put parentheses when I substitute multiple objects, there's no purpose for the parentheses. So I'm going to go ahead and rewrite it now without parentheses. X plus 17 minus 3x equals 7. If I'm solving for x, I want everything x on one side, everything not x on the other side. So I'm going to move the 17 across the equal sign. Plus 17 becomes minus 17. On the left, I've got 1x, which is what I've got there. 1x minus 3x is negative 2x. I subtract because the signs are different. It's negative because 3 is bigger than 1. 7 minus 17, once again, different signs, subtract gets me 10. 17 is bigger than 7, it's negative, so negative 10. We divide both sides by negative 2, which leaves me with x equals 5. So up till now, x could be anything we want it to be, but now x has to be 5. 5 is the right answer for x. My only other task now is to figure out what y has to equal in that scenario. So I take the answer I just found, x equals 5. I go back any place containing both x and y. The best place to go is my substituting equation right here. This says x equals 5. This has an x in it, which equals 5. So this equation transforms from what it is into y equals 17 minus 3 times 5. Again, instead of 3 times x, I'm writing 3 times 5 because x equals 5. you're gonna find out x equals some number, that's what you replace there. And then just work that out. So y equals 17 minus 15, order of operations, multiply first, subtract second, 17 minus 15 equals 2. And once we know both x and y, we get 5 comma 2. Now, I don't want anybody writing anything else I'm about to do down on their paper because it'll be confusing, okay, and I don't need confusion. But I just want you to see just a visual of what happens if you make the wrong choice, that Journey made the right choice, right? She said solve the top for y. That was one of the 3 good choices. The one bad choice would have been solve the top for x, right? So if I had done that, here's what my work would have looked like. I would have gotten 3x equals 17 minus y, right? I'm going to get x equals, so I got to move everything not x to the other side. Then I divide by 3. So x equals that. Then, that came from the top equation, so I have to replace this x here with this expression here. So it says x plus y equals 7. I change it into 17 minus y over 3 plus y equals 7. Still substituted it, still legally did everything I'm supposed to do, right? At this point, I'd probably break that fraction apart, so all of a sudden I've got 17 over 3 minus y over 3 plus y equals 7. And I would probably, for me, multiply everything by 3 to get rid of those fractions. So 3 times 17 thirds is 17. 3 times negative y over 3 is minus y. 3 times positive y is positive 3y. 3 times 7 is 21. Move the 17 over here. Positive 2y, subtract because the signs are different. Positive because 3 is bigger, equals 4. Subtract because the signs are different. Positive because 21 is bigger. Divide both sides by 2. And we get y equals 2. Exact same writing as we had over there, but look at all the mess we had to go through to get to it. So, the moral of the story here, after we found y equals 2, we'd go back here. 17 minus 2 is 15. 15 divided by 3 is 5. X would equal 5. So we get the same answer, because that's what the answer is. But if I'm going to use substitution, if I make the decision, I want to do substitution, look for a coefficient of 1. 1y, 1y, 1x. Get that to equal everything else. That creates the easiest problem possible. Going for the one with not a 1 in front still works, it's just not as pleasant getting the answer. It's a little bit more challenging, so we're trying to avoid challenge whenever possible. That's what I want you to consider.